Okay, picture this. You're staring at a mountainside, maybe, or perhaps a vast open pit mine. That's where, many of the world's most critical metals come from. But now, picture something else entirely. A scrapyard, maybe. Piles of old cars. Because tucked away inside lots of those vehicles is another source, one that's already above ground, just waiting to be unlocked. We're talking about catalytic converters, specifically the precious metals inside them, platinum, palladium, rhodium. These aren't just valuable, they're, well, absolutely essential, not only for cleaning up exhaust fumes, but increasingly for clean energy tech, too.
And historically, getting those valuable platinum group metals or PGMs back out once the car's finished its life, that's been a tricky business,
Mm.
especially from certain types of converters like the silicon carbide ones you find in a lot of diesel vehicles.
Ah, I
Traditional methods can be really energy hungry or use pretty harsh chemicals, or sometimes they just aren't very efficient for these specific materials, which means a lot of potential value and critical resources just get left behind.
And that's exactly why the sources you've shared with us are so exciting, really. They point to this company called Regenx Tech Corp, which is tackling this exact challenge head on with a completely new, clean technology. It feels like a genuinely innovative solution to, well, a really significant problem as we move towards a more circular economy.
Yeah, what really stands out is their approach. They seem to be bypassing the high temperature smelting or the really aggressive chemical leaching
Yeah.
that have been the norm for so long. And this has massive implications, not just for environmental sustainability, which is obvious, but crucially for securing the supply chains of these critical metals going forward.
Right. So, our mission in this deep dive is basically to take this stack of sources and unpack everything. What exactly is Regenx technology? Why is it so important both environmentally and economically? Where are they right now on their journey? And, what's the big potential here, especially for major players in the automotive industry, maybe even right here in Europe? Let's dive in.
Let's do it. It's actually quite interesting to trace Regenx's path. They didn't just start with catalytic converters. Their roots are more in the traditional junior mining world, actually.
Yeah, interesting.
But they pivoted. They recognized the growing importance and, frankly, the potential in eco-friendly materials processing. Before they focused on autocatalysts, they were working on processing old mining waste and even got into e-waste recycling for a bit.
Okay, so they already had that core expertise in finding cleaner ways to get value out of complex materials. That makes a lot of sense then. And they zeroed in on catalytic converters after connecting with a partner, Davis Recycling, was it?
Yes, Davis Recycling. They became their operational partner for the autocatalyst side of things. Regenx began lab testing their process specifically for converters back in early 2020. They basically took their background in chemistry and materials processing and started scaling it up. First from the lab, then to a pilot plant located in Alberta, Canada.
Ah, the pilot plant. Okay, that's where you move beyond the beakers and flasks, right? You really see if the process holds up on a larger, more continuous scale. Testing production capacity, recovery rates. Did the sources indicate that pilot phase went well? Was it successful?
They did, yes. The pilot work essentially validated the technology's effectiveness at that larger scale, which was, the critical step needed before they could even think about moving towards commercial operations.
Right, makes sense. And the next big step after proving it at pilot scale is, of course, building the actual commercial plant.
Exactly. And Regenx has now built that commercial scale facility. It's located in eastern Tennessee in the United States. The sources mentioned this plant is currently in the commissioning
The
phase.
commissioning, right. That's
Mm,
basically the final tuning stage. Testing, calibration, before it goes into full operational production. It's where you sort of iron out all the last wrinkles and confirm everything works as designed at maximum capacity.
That's precisely it. And the initial module they've built, it has a design capacity to process about 5,000 pounds of catalyst material per day. But the plan, as outlined in the sources, is actually much larger. They intend to significantly expand this facility. They're talking about adding 3 additional modules, which would bring the total plant capacity up to 10 tons of material per day.
Wow, 10 tons a day. That really puts the scale of the opportunity into perspective. Now let's get into the heart of it. The technology itself. The sources use terms like proprietary and chemical-free.
Mhm.
How does this process actually work, and how is it different from what's been done traditionally?
Well, what's really compelling here is the contrast with those traditional methods.
Hmm.
For decades, the industry has pretty much relied on either extremely high temperature smelting, which is, very energy intensive, produces significant emissions,
Hmm.
or using strong, aggressive chemicals to dissolve the materials and extract the metals. Hydrometallurgy, Regenx's approach, their proprietary process, it avoids both of these routes. It is a chemical-based process, yes, but the sources really emphasize it doesn't use those harsh, aggressive chemicals that are typical in traditional methods.
Okay, so it's inherently a much cleaner starting point, environmentally speaking. And when you say proprietary chemistry, what does that translate to in terms of getting the precious metals out effectively? Are they leaving much behind?
The sources seem quite clear on this point. They state that the technology achieves a really high recovery efficiency, extracting over 95% of the precious metals from the converters,
Over 95%.
which is absolutely critical because, as we mentioned, these metals are incredibly valuable. If your recovery rate isn't high, the process just isn't economically viable no matter how clean it is. You have to capture that value.
High recovery and a cleaner process. That is a powerful combination. And the sources also highlight that their technology is particularly effective for a specific and growing segment of the market, those diesel converters, especially the ones made with silicon carbide substrates.
Yes, and this is a key differentiator and, frankly, a major market opportunity for them. Diesel converters, particularly the CSICAN ones, are notoriously difficult for traditional smelters. Smelters often struggle to process them efficiently, sometimes leading to lower yields, higher processing fees. Sometimes they even refuse the material outright.
Really?
Yeah, this represents a huge bottleneck in the recycling chain. It leaves potentially billions of dollars worth of precious metals unrecovered. Regenx's technology is designed to specifically address this challenge and do it with high efficiency.
So just to trace the flow, they take the catalytic converter material, which is ground into a fine powder that's handled by their partner, Davis Recycling.
Correct. Davis handles the front-end processing, the decanning, and grinding.
Okay. And then Regenx applies their proprietary process to this powder to extract the PGMs. And the output from their process is a concentrated powder, often called black powder in the industry, right? Which is then further refined to a high purity level, like 99.9% before being sold on.
That basically outlines the core process chain described in the sources, yes. It shows how they integrate with existing feedstock providers like Davis and then apply their unique extraction method to produce a high-purity product ready for the market. But understanding how they do it is only one part of the story. The other is understanding why this is so strategically important right now.
Right, the so what question. Why should anyone, especially large industrial players like automakers, be paying close attention to a more efficient way to recycle old car parts?
Well, if we connect this to the bigger picture, it really boils down to critical metals and supply chain security. PGMs are absolutely essential in modern manufacturing. As you mentioned earlier, palladium's primary use is in catalytic converters. Something like over 80% of its global supply goes into them. They're needed for traditional emissions control, yes, but they are also critical components in hydrogen fuel cells and other clean energy technologies that are, a big part of the future.
And where does the primary supply, the newly mined supply of these metals actually come from?
The vast majority of the world's mine supply comes from just two countries, Russia and South Africa, which creates a significant geopolitical risk factor, obviously. Add to that the fact that for years now, demand for PGMs has consistently outstripped the mine supply. The sources mentioned an average annual supply deficit of about 259,000 troy ounces over the past 8 years. It's a real supply squeeze. And governments, including the U.S. government, have formally designated PGMs as critical minerals precisely because of this vulnerability.
So it's not just an environmental issue anymore, it's genuinely a national and economic security issue. Relying so heavily on mining from just a couple of regions that could be potentially unstable, that sounds risky. And mining itself is just a massive undertaking, capital-intensive, energy-hungry, pretty disruptive to the environment. It really sounds like recycling these metals is maybe the only truly sustainable path forward.
It's certainly presented in the sources as the most viable, sustainable option to help bridge that supply gap and meet future demand. But despite the clear need, the sources indicate that only about 35% of the total annual PGM demand in 2023 was actually met by recycling.
Only 35%, wow.
Yeah. That leaves a massive amount of materials circulating in end-of-life vehicles just waiting to be recovered.
That percentage, only 35% of demand met by recycling last year, that is a surprisingly low number, isn't it? Given how valuable and critical these metals are, it really underscores the scale of the opportunity for more efficient recycling and the environmental benefits compared to mining. The sources cite some pretty striking numbers there, too.
They really do. Compared to traditional mining methods for PGMs, Regenx process reportedly generates 95% less CO2 emissions.
95% less CO2.
And uses 99% less water.
Wow.
These aren't just marginal improvements, they are orders of magnitude better environmentally. This aligns directly with the increasing global push, especially from manufacturers, for, true closed-loop production cycles and verifiable reductions in their environmental footprint.
Wow, 95% less CO2 and 99% less water. Those numbers are just incredibly powerful. It makes it crystal clear why companies with serious sustainability goals would be very interested in this kind of technology.
Exactly. And this is precisely where the strategic opportunity for major players, particularly automakers, really comes into sharp focus.
Yeah, I can see that connection immediately. Automakers face immense pressure from regulators, investors, consumers to demonstrate real progress towards sustainability and a reduced carbon footprint. Having a reliable, verifiably clean source of recycled PGMs would directly contribute to those goals, wouldn't it?
This is precisely why the sources discuss this significant opportunity for partnerships. They specifically mention the potential interest from companies like Stellantis and Renault. Now, while there's no public confirmation of specific ongoing negotiations at this moment, the strategic alignment is pretty compelling.
Okay, why focus on them or automakers like them, particularly in Europe?
Well, Europe is really at the forefront of environmental regulation and has set some very ambitious targets for a circular economy. Regenx has also publicly stated their interest in expanding into the European market and apparently have already seen interest from potential European partners and investors. So for major European automakers like Stellantis or Renault, integrating a technology like Regenx isn't just about securing material. It's potentially a very powerful way to strengthen their position as leaders in sustainability. It aligns perfectly with their stated commitments to reducing environmental impact and ensuring responsible resource management.
And the sources specifically mentioned Stellantis being quite open to collaborating with startups and integrating sustainable technologies. It really sounds like partnering with a company like Regenx would be a very tangible way for them to demonstrate progress towards their sustainability pledges, improve their supply chain resilience, and maybe gain a competitive edge in a market that's increasingly scrutinizing environmental credentials. Plus, by addressing that specific challenge of those hard-to-recycle diesel CC converters, Regenex offers a unique technological piece to that whole puzzle.
It really comes down to securing critical materials in what is a volatile market, while simultaneously boosting their environmental performance in a way that's measurable and verifiable. The potential benefits for a strategic partner seem quite clear. Enhanced supply chain security, a dramatically reduced environmental footprint, those huge reductions in emissions and water use compared to mining in alignment with increasingly stringent regulatory and consumer demands for sustainability.
It's fascinating how this one technology seems to address so many different angles at once: environmental cleanup, resource recovery, supply chain resilience, and of course, economic value creation. Of course, bringing any new technology to commercial scale and navigating new markets, that's rarely without its hurdles, right? The sources touch on some challenges Regenx has faced.
Yes, they do mention challenges. Things like building trust with investors while the technology is still being scaled up, navigating the timelines and complexities of commissioning a new plant, especially permitting issues when moving from development in Canada to actually building in the U.S., dealing with local regulatory bodies in Tennessee. Standard challenges for this kind of venture, but challenges nonetheless.
And how did they reportedly navigate those challenges? What did the sources say?
The sources seem to highlight factors like maintaining transparency with stakeholders, careful engineering and planning, and building strong collaborations, both with their operational partner, like Davis Recycling, and the technology teams involved. It speaks to the leadership and the foundational approach of the company, really.
Speaking of leadership, the sources note that Don Weatherby took over as CEO in 2024. He'd been president for the 2 years prior, working closely with the previous CEO. He sounds like he has a strong background that's pretty relevant to scaling a company like this.
He does, yeah. His background includes over 20 years in senior roles spanning mining, construction, technology. So a good mix of financial acumen and operational experience. He holds certifications like CPA and CMA. The vision he's promoting, as described in the material, is clearly centered on ESG principles: environmental, social, governance contributing to the circular economy, and positioning Regenx to become a global leader in clean metal recovery.
It really paints a picture of a team that is not only technologically innovative, but also strategically focused on that bigger picture of sustainability and resource management. They're not just building a plant, they seem to be aiming to be a key enabler of a fundamental shift in how we recover and reuse valuable resources.
That really seems to be the core of their mission, based on the sources, to be an innovative and responsible leader in precious metal recovery through a clean, sustainable technology. And they have a clear path outlined towards international expansion. The strategic window, particularly for major automotive players looking to secure their critical material needs and meet those ambitious environmental targets, it appears to be wide open right now. And given Regenx's stated interest in Europe and the continent's leadership in circular economy initiatives, the alignment for potential European partners seems particularly strong.
This has been an incredibly insightful deep dive. Really fascinating stuff. We've explored how Regenx has developed this clean, high-efficiency technology to recover PGMs from catalytic converters, specifically solving the challenges posed by those tricky diesel silice materials. We've followed their journey from pilot scale right up to commissioning their first commercial plant in Tennessee, and we've examined the immense strategic importance of this innovation for sustainability, for securing critical metal supply chains, and the compelling opportunity it presents for automakers, especially potential partners maybe in Europe, to gain a significant competitive edge and really solidify their sustainability leadership.
It really does underscore the potential for some groundbreaking innovation right at that intersection of environmental necessity and industrial strategy.
Which brings us to a powerful thought for you, the listener, to consider as we wrap up. Given the twin global pushes towards vehicle electrification and the urgent need for a robust circular economy, how will the efficient recycling of the hundreds of millions of combustion engine vehicles that will reach their end of life in the coming years, how will that fundamentally reshape the automotive landscape of the future?
It's a challenge, definitely, but it's also a profound opportunity for resource management and industrial evolution.
Definitely something to keep thinking about. Thank you so much for joining us for this deep dive. We hope you found this exploration of Regenx and the critical world of metal recycling as fascinating and, well, eye-opening as we did.
There's certainly a lot of potential here for positive impact, for sure.
If you enjoyed this deep dive and want to stay informed on more topics like this, please just take a moment to give us a like and subscribe to the channel. It really helps us bring more explorations like this directly to you. We appreciate you being with us, and we'll see you on the next deep dive.